I'm here with Tom to talk a little bit about what we found during our involvement with SEBA and while building systems, and therefore the presentation is about a reality check for SEBA and how we think that the design could be taken to the next level. And I think as first thing, Tom will give you a little bit of a quick background on what SEBA is.
Okay. Like they need that, right?
So we'll try to go fast.
All right, we'll go fast. So to start off, I think none of these things should be a surprise for anyone in the room. That the goals for SEBA definitely were to do something as a community, not individually, and to develop broadband access system. We really are encouraged, and we want to enable third parties to build offers based on SEBA. We're not buying everything from ONF, for example. And we really need to integrate with existing OSS, BSS, and systems that are part of the carrier's infrastructure today. But we also really want to minimize the upstream concerns for these systems. And I think you heard Hans-Jörg talk about the Las Vegas principle, right? And it's also the basic layering principle in computer architecture, that you want to hide complexities from one layer from the concerns of the next. And we wanted to be able to do these capabilities across disparate kinds of access, GPON, GFAST, Telegraph, whatever, right? And avoid lock-in. And it, of course, also means lock-in from potentially projects in the open community. So the architecture for SEBA you've probably seen 100 times. I won't belabor this, right? There's lots of components here, Volta, ONUS, Trellis, NEM, that we all understand and have come to know and love them. And so I guess I'm going to say we have, from within AT&T, for example, we have a sort of a deployment model in mind with SEBA, and we've shared this, of course, with our workflows and whatnot. And you can see here with the sort of blue highlights in this picture, the components that we're intending to consume within AT&T for the SEBA architecture. And then there are also other components. And you can see here, for example, the aggregation devices are not the Trellis component. We have the Acrano providing the basic underlying up to the Kubernetes level that SEBA gets installed on top of. And as we talked about earlier, all those northbound systems that are existing and we have to deal with because they've been there since before I was born. Sorry, maybe not all of them, but we have to deal with those.
You're so young.
Yeah. So all those things have to be dealt with as well. And then I guess now I'll give Fabian a chance to say the similar things.
Yeah, right. So I don't want to walk you through the whole slide because Hans-Jörg and Robert gave a very good introduction on to what A4 is doing. I just want to do 3 highlights basically on this slide. So the first highlight is in our deployments that we envision, we are planning to go for around 1,000 pods that we want to deploy. So that also means that each pod is fairly small as compared to potential other deployments that are around. The second thing that that is worthwhile to point out is that in our design we want to basically, as also has been highlighted earlier, we want to integrate several functionality into our fabric. So, for example, we want to integrate the service edge into the leaves and the LER functionality into the spines. And that comes and brings some additional challenges with it. And therefore, basically, in our deployment, the SEBA design can't be a one-on-one mapping to what we build. And I'll get to the details on that later. Actually, right now. So we split the talk a little bit. I'll go first, delve a little bit into what is specific to our deployment, and then Tom will continue and wrap up. Okay. So first of all, there were some principles that we used while we built the Access 4.0 project. And I mean, they are not necessarily new or anything special, but it's still, I felt like it's necessary to point them out because they actually did influence our design later on. So first thing is we want to be extensible for future access technologies. That basically means that we need to be able to accommodate different technology stacks into the system, and different technology stacks might come with different also software control architectures. Second thing that we want to do is we want to follow SDN principles. So we want to have a disaggregated design. We want to go ahead and control what is going on in the network, have our business logic basically dictate what is going on, and be in control of our business logic, that we are not necessarily needing a vendor to implement our next best product that we want to launch on the market. At the same time, given that our system will replace our current BNG infrastructure, we need to at least achieve feature parity with our BNG, because otherwise everyone in our company will tell us, it's nice what you built, but what we have is way better, so we'll stick with what we have. Then again, disaggregation, very important. And now the most important bullet for me actually is the vendor neutrality. So we want to have, for most of the systems, ideally for all, the option to have a second or a third vendor to replace the systems that we have, so that we can actually use the one source. And with source, I'm not necessarily saying it has to be a commercial vendor. It can also be an open source project or whatever it is. But we have to have the possibility to swap individual components out, so we can actually go for the system that gives the best performance, the best price, the best whatever it is. And as Hans-Jörg already stated several times, Las Vegas.
Viva.
Okay, so this will basically be a build-up of our control architecture, and this is what people alluded to when they told you, look, wait for Fabian to explain what we do on our control plane. I'll try to do it here. So basically, at the very bottom, what we have here are our hardware, ASICs, FPGAs, whatnot, that we have there. Also OLTs and so on and so forth. So the first thing, as I said, is we do have different technology stacks. And one technology stack, probably the most important for this community, would be the OLT-ONT part. And if you can move on. So, but we do also have different ones. So we do plan to also go for a DPU deployment. So we also have something that plugs, another thing that plugs into the OLT. We will integrate DSL at some point in time. We will have things that implement basically our service edge functionality, and we will have a fabric and label edge router functionality. So these are basically the agents that sit directly on the hardware that control what the data plane is doing. Sorry. So now when we're looking at one level higher, basically from the individual elements to the pod level, we will have controllers for each of those agents. As you can see, it's the same thing again, and this follows basically the main idea of disaggregation. The thing that popped up there in the corner over there is basically our radio server, or the source for our subscriber policies, that also needs to be integrated. And this is what we get next. This is basically now the pod access orchestrator, as we call it. Could also say master SDN controller or whatever. But this is basically the thing that interfaces with our policy databases, which interfaces with the source of the information, what to do with a specific subscriber line that comes in, that plugs into our pod, and will make sure that all the systems that are part of the deployment chain to actually do the right thing. So the pod access orchestrator sits on top and controls all these other things. And now, with the next step, that means that we need interfaces between there. And those interfaces need to be at least agreed in the community. We will work on those, and once we have good candidates, we will come back to you. That's a promise. You can take me up on that. But I've been in standardization for quite a while, and I know that it's not worth starting to talk about stuff that is not there yet. And especially that is not there yet working. So with that in mind, we are trying to get these interfaces in place and then bring them to the community. Again, ask for your feedback. If there are things that we are missing that can be improved, we are happy to do And basically, with these interfaces, what we can also go and do is replace individual pieces in this architecture. So we can go ahead, and if we say OLT controller that we currently have, there's another good option. Let's try it, plug it in. Obviously, it needs to adhere to the interface, or it needs to at least have an adapter that plugs into the interface, and then we can go ahead. Okay? So as the next part, maybe one more click. What we're currently planning to do is basically use Volta and ONOS as our tandem for passive optical network control. And that answers Asim's question. Yes, we do still use ONOS, but we only use it basically for this part of the whole pod. We're not planning to use it for another part right now. And if you can go ahead, and that brings us to the other thing. When we're looking at service edge fabric and label edge router functionality, this is what we're currently developing with our partner RT-Brick. RT-Brick will basically build the control plane for the devices itself, and we will have small pieces on top that make sure to control that. And if you go one more, this is actually how it will end up in the look in the end. Point is, the LER controller we will probably directly integrate in the power because it will be only configuration. So external to our pod, we will need to interface with our existing IP routing plane in the backbone. So this is basically just configuring the adjacencies, configuring the right interfaces. For the service edges, we are in a similar situation, and there the point why we elected to integrate it directly in the power is each service edge instance that is sitting on the elements is kind of on its own. It will always require its own configuration. It doesn't depend on any other of the pieces in it. So this is why we decided to pull that up. And the fabric controller we will keep there. For the time being, we will probably go with something very lightweight. At some point in time later on, we will probably try to get that integrated into the deployment and sourcing from RT-Brick, or maybe yet another place. Okay. We do also have the whole thing that is about feature parity, and just go ahead, just bring them all on. I won't go through all the details here. You can read it later on. But this is basically the functionality that we see currently sitting in the POW. And with that,
one more.
Yep. Just go ahead. So now, when I'm looking at our designs that we evolved or that we developed and the SEBA architecture, this is basically how we see the overlap. The good thing is, on the data plane, it's pretty much a perfect match. So we do basically use the BNG as a PNF in the aggregation switches. Check. We do have compute. We do have label edge router functionality. We do all the GPON stuff as it's intended. We pretty much use the interfaces that are mentioned here and there. But when we're looking up a little bit, it differs. But parts of these differences are due to the fact that our OSS systems are different, as Tom already said. So we need to plug into those. And another part is that we basically said we want to make on the NEM or control level, we want to make the split between things that are basically network and policy control and things that are management. And that's basically it.
Okay. I know you have a few more.
So, coming to my final points. So, with that said, I think there are some things where the SEBA design can evolve a little. First part is, given the fact that we're building quite a bunch of these systems, what is important for us is really that we have all the individual systems that need to run in each pod are as simple as possible. So also a micro-based service approach is really nice in principle. Having too many microservices that you need to take care of also makes it a little bit hard. Same thing is when we're looking at what the individual systems are needing as helper components, like for example a Kafka for Volta or another message bus for something else. Again, it would be very useful to stick with systems that are easy to deploy, that don't require yet another 3 components, and microservices to run, like, for example, a Kafka with a zookeeper in several instances. Next up is we really want to allow different sources for our components. And with different sources, I mean both in-house development, open source developed, proprietary, whatnot. So we really need to get to a design that allows a plug-and-play Lego-like system, where you can take a piece from here and a piece from there, stick it together, and it still works. Exactly. And in order to get there, I think the crucial piece is that we get to do that by using and getting very thought through interfaces which abstract functionality across the different levels. Similar what Hans-Jörg said with the different APIs that we want to have between all the different pieces of the stack. I already told that we want to bring those into the public, and what do we have last? Yeah, and this again is kind of, there will be pieces in every deployment of a SEBA-like system that are very unique to the individual operator, to the individual deployment, to the individual scenario that there is. So basically, this is why we decided to go for a co-development, and for the time being, we decided to keep the pod access orchestrator as an in-house development, because we really need to see how far we can basically open source this. It will also host a lot of our business logic, and we're not necessarily keen on opening that up to our competitors. So this is really a component where we see a little bit of a tricky place when it comes to open sourcing this. But the rest of the whole system, I think we're pretty much good and say, hey, go for it. Also, I think we need to focus a little bit on where we want to go for production readiness of specific components. And in our view, the most important piece here is the Volta system. So I welcome all the good progress that has been reported today and yesterday, and keep up the good work. And I think that's it from my side. There's one more, actually. Sorry, that slide is Manuel's fault. He wanted me to stick it in. So he's sitting back there, so complaints go over to him. The crucial point is, we are not holding back with our insights, and we try to actually feed them back into the community. And as you can see here, this pretty much looks like what we have in our deployment. So let's just keep talking and evolving the system.
Okay.
With that
you did it. Excellent. Okay. So it's okay. Now we're going to have the same sort of view, but from an AT&T perspective. When Fabian asked me to join, the first thing was, well, okay, what would we want to message about taking SEBA to the next level? And I started thinking about, well, what are our pain points now? And so before I jump into this, let me not say that you should stop what you're doing. You want to keep going and get what we have out and into the marketplace, right? This is sort of what comes next. It's not intended to be the shiny bauble or the thing the squirrel chases. So we have within AT&T probably a lower population density in a lot of the places we serve than there is in Germany. And so there is a strong desire to take a SEBA and run it into what I would call much smaller, scale it down, if you will, smaller kinds of deployments, and actually to run it right on the open access hardware. So if, for example, we have an office and there's only a need for one OLT or some plugs from Tibet to serve that environment, stacking up a bunch of servers right next to those couple of plugs doesn't look really good from an economics perspective. How do you get to use the same SEBA, you leverage the open source, but shrink it down to mini-me size? So that's one of our pain points right now. And there's also a need to adapt SEBA to existing large-scale systems. And when I say large-scale systems, I mean the OSS and BSS, the systems. And of course, the economics have to be on par with legacy systems. And if you can buy a little pizza box OLT today that has everything all built into it, and then if you want to change that out for SEBA, now you get the little OLT, but then you have 3 servers, and you've got an AG switch, and you've got a trellis thing, and that's not so good. And then the other thing we find is that the things that you want to build upon, the apps that manage your access, right now they're kind of limited by open flow protocol capabilities. So if, for example, I want to create a topology, I can do that just fine from behind ONOS, and we have a lot of attachment tools that do that. But if I want to start managing things like scheduling, and I want to manage things that are not part of what I call match action rules, I have to go around the side. I either have to build profiles or metadata or other things that wind up sort of working around the protocol to get things done that we need to do in the access. So those are our pain points today. Most of you know this stuff. It's not new, right? We know about the profiles. We know about the metadata. This is, just sort of a thing. So, and I think we also recognize, by far the jewel here is Volta in the overall SEBA. In fact, SEBA, I think, is really sort of the surround we decided that we would need in order to bring Volta to the market, right? And so let's remember that. And we like Volta. It's built on a robust system. It's really cool. Everybody loves Volta, right? Does anybody not like Volta? Just checking.
Out of the room right now.
So we think that one of the ways that we are successful as a community is to make Volta actually indispensable, not just within SEBA, not just within ONF, but much more broadly, right? And so adding capabilities for more silicon and devices, that's a no-brainer. Enable low-end systems, and I'm going to talk a little bit more about local APIs. And I think the local APIs would both help with shrinking down, also help with high performance. And like I said, I'll get there in a second. I think everybody understands you're already on the path of using performance software languages, and there may be more to do there or maybe not. It's kind of what comes up. And then we can also redefine what makes a minimal viable product. It seems that the packaging we've done around SEBA and may include things that are not necessarily being used by any of the carriers. We need to kind of sanitize that and make sure that we're working on the things that matter to the users at the end of the day. So instead of a lot of these things, I think people probably have picked up on. There's already an understanding in the group. There's already activity going on. One that I don't think, and I wanted to kind of focus on and just kind of give an example, is the whole local APIs concept and how that might help with shrinking down a deployment architecture. So I'm going to start with a story because I love stories. We're going to look at a box, and you can see on the right, this is an old school switch. This is how things used to be built in the olden days. You'd pick some kind of ASIC at the bottom, and it would come with a driver and an SDK that was sold by probably the manufacturer of the ASIC, and you had to learn how to program that SDK directly. You'd have some kind of OS. It might be real time, it might not be real time, and in that OS you would create a bunch of modules. You'd have various kinds of control plane stacks, or like your OSPF or BGP. You'd have other control functions that might be either autonomous or management class functions, things like your 802.1x, for example. And then you'd have a number of management interfaces at the top that you could actually use to configure the box. Okay, well, I said I was going to look at an adjacent market and see if you can guess. So one of the things that has been done elsewhere is they've developed sort of a switch abstraction interface. It should be kind of familiar for folks. And what that allowed is that you could have independence from the SDK and the driver for different merchant silicon. This is a concept, this should not sound strange for Volta engineers, right? But it also meant that you could have your control plane stacks, your other control functions, and sort of your NOS much more homogeneous, and you had a sort of an independence against that. And then those adjacent folks came up with sort of a common infrastructure for what happens all the time in switch after switch. And so you have services that maintain your local state so that when the thing boots up again, it can come back to where it was. And you have control modules that might be stacked up within sort of a common bus architecture and a common set of services underlying it that make it simpler to create those control modules. And without digging into a lot of detail, that's something that the adjacent industry is selling as Sonic. Now, if I remove the name Sonic and put the name Voltha, here's the test. What's different? Not very much, right? So my point here is that through a parallel activity, we've come basically to the same conclusion or the same basic architecture within Voltha. We have an access abstraction interface. We abstract the silicon underneath. We have a basic state service within Voltha. We have modular control capabilities, and then we have northbound interfaces. So two different communities doing different things, coming up very much to the same conclusion. The one thing that is different, are you ready, is that in the adjacent industry, you don't have to leave the box. You can also build your control applications against APIs, those control modules, right there in the local space. And I believe that one of the things, it's not even a big thing, I believe one of the things we could do to make Voltha that much better is to have an architecture whereby the applications that right now sit on top of ONOS have an opportunity to have a similar API that's local, could run in the same box if you're doing a SEBA in the box kind of deployment. And this modularity allows you to either plug in an extension cord and keep the existing architecture, or to move apps in. It allows you to scale up, it allows you to scale down, and it uses the same basic system architecture. I didn't want to overthink it. It's an idea, it's a concept, and I think it adds value at the end of the day to Voltha. So, it's my summary time. We think Voltha is great. Focus on Voltha. Keep focused in general. We really want to deploy this and allow for extensibility and enable both local and central functions. So, now, release the hounds. Okay.
Yeah. Thank you. And if you have questions, feel free to shoot. Raise your hand. I can bring you the mic.
I'm in favor of what happens in a pod stays in a pod, but what happened, there's a problem with the pod, how do you get that, the status of the pod?
So, that's a good question. And basically, the point that we're saying, we build something that is independent from the rest of the world. Obviously, depends on the capability to at least have a stable system in the pod in general, but also have some mechanisms that allow you to debug it. And maybe I did not highlight that as we have it today, but basically through our systems and APIs, we do plan to collect also a lot of measurement data. We will also be able to work together with our operations people in order to, immediately go ahead and put the debug cases that will happen and that will probably also evolve over time, to put them into the pod as much as possible. But if it's necessary to, for example, correlate failures across several pods, that is not something that we say should not happen. So we will do a lot of reporting of all the collected information towards our central side, and this is basically what Hans-Jörg talked about with our EMS and the NEMO part, where we do want to also collect all the information from all the pods, but we want to also be fairly
Is that right? No guns,
okay.
Careful, Fabian.
I
think you're going on.
I get it. Beer is calling. I get it. No, but what we do want to do is also have the possibility to, if we say this is a typical failure that where a diagnosis is only needed within the pod, we will try to implement it in the pod. and then basically obviously offer some sort of interface towards the operators to use that, and that would then go through our APIs that we put in place.
Right.
Yeah, but good question.
Can I say something too on that before?
Sure.
You
have a mic.
I do, but I love to talk.
Yeah,
I just
go
wanted
ahead.
before we go. So one of the things that I think is it might be a common problem, and that is that when we do new things in a network as a telecom provider, often there is a boatload of IT work in OSSs, in systems that are needed to energize that. And I think a lot of that work is because every knob, every lever, every capability from the network is completely shown up today through EMSs and whatnot into those systems. So they have to be concerned with things that probably don't belong at a large central layer. You have this vision that around SEBA that if in an implementation you could get access as a service. Your upstream systems care about the service. They care if it fails or doesn't fail, so there you do need to know when that happens. But if you can tell the SEBA pod that you worry about how to connect from the access point to the virtual BNG or the physical BNG inside the pod and keep track of the connectivity among different components. Maybe also keep track of how you scale out the containers if you have elastic capabilities inside. None of that needs to be the concern of a centralized location. And that helps, if the IT systems don't have to worry about all that minutia, they get simpler and simpler and simpler. And hopefully, as we go forward, new kinds of capabilities don't become, long projects with millions of dollars of IT work.
Exactly. More questions?
Boredoms.
Okay.
They know there's beer.
You want beer. Go for beer.